Our last objective in this section is to help us to kind of think through what periodic functions are and what they look like. And that's what we discovered using sines and cosines or trigonometric functions, is that it helps us observe many of the things that we see in nature around us. I mean, for example, the tides when we go to the beach. The tides rise and fall roughly every 12 hours. So we would say that the tides are that represent a periodic function. So how we can kind of translate that into the terminologies we've been using, we can look at some periodic function. Some function, its periodic function represented by t plus its reoccurring period would also, so all that would, so that's where we get some function, its value will equal itself at some regular interval afterwards. And we're already starting to see this with our sines and cosines. We know that the sine, we get to the same value every revolution or rotation around the circle. So we can say the sine with some value t plus another revolution or rotation around the circle would see this, it would equal the sine of t. And likewise, we can see that with cosine as well. So the cosine of some angle plus a full rotation around the circle will produce the same value as t. So given that, we could say that the sine and the cosines have a periodic function of 2 pi. So let's see how that plays out with an example here. So the cosine of 420 degrees. And I know this is looking a little familiar earlier because we started talking about coterminal angles a couple sections ago. So it's the same idea, but we're going to use this idea of periodic functions with that. So the cosine of 420 is the same thing as 360 degrees, one rotation, plus what's left over after that, 60 degrees. And since the cosine of 360 degrees plus 60 degrees is the same thing as the cosine of 60 degrees, so now I just got to figure out what was the cosine of 60 degrees. And again, that's one of the things that, one of the primary angles that pops up all the time. And so that was 1/2. Another example, sine of 9 pi over 4. That's a periodic function. With that, I can see that's the same thing as the sine of pi over 4 plus 2 pi. And the sine of pi over 4 plus 2 pi is the same thing as the sine of pi fourths, because it's on its periodic rotation, its periodic function, and the sine of pi fourths equals root 2 over 2. Again, one of the values of the common sines or cosines that we see. So cosines and sines have cosecants and secants have a period of 2 pi. Tangents and cotangents are different. The cotangent or the tangent has a period of just 1 pi. So rather than 2 pi, which completes a new period, the tangents and the cotangents have a period of just 1 pi.